Hey guys, you can learn a lot about STMicroelectronics and the various kits that they're providing in order for you to connect very easily these tiny devices up to Azure IoT in this video on the IoT show. Hi everyone, this is Olivier, your host. You are watching the IoT show, and today I have Manuel with me. Manuel is coming from the STMicroelectronics silicon vendor, and we're going to talk about hardware, kits, developer stuff. Hey Manuel, how are you doing?
Hi Olivier, how's it going?
Thanks for coming here.
Yeah, you're welcome. Thanks for having me.
So can you tell us a bit about yourself, and then we'll talk about STMicroelectronics.
Absolutely. So I'm Manuel Cantone. I'm IoT marketing in US within the IoT promotion and enablement team for STMicroelectronics. So what we do is we're a silicon vendor. So our core business is to provide silicon products to developers to build their own smart things. But my work is to try to identify solutions and identify synergies with partners to give developers ready-to-go solutions that let them, that basically simplify their journey from idea to product. We want to take them 80% there and then have them develop only their own novelty, their own ideas.
So you're building these chips. So what's your typical customer? Like, you don't have to say names if you don't want to, but what is the typical kind of things that your customers are building with your chips?
An example can be the watch that I'm wearing. Is a perfect example of things sporting IoT products. And our product line is really, it's a very diverse product line in the silicon area. We are positioned in a way that we can basically give you products for a lot of sectors supporting the IoT. So we are a leader in the market of ARM Cortex-M based microcontroller. And that's the process that every IoT node. But we also have a security solution, power solution to power and battery charger, linear regulators, DC regulator and stuff like that. Full motor control portfolio, signal conditioning, but also sense, the connection to the real world. We are one of the leaders in MEMS sensing technology. We have a full portfolio of MEMS sensors and actuators. And on top of that, the connectivity, the AI in IoT. How do you get from the real world through some means of processing to the cloud and then.
I think you told me a number in the past of like how many of the STMicroelectronics chips are out there.
Yes, and I have a different number for different families. So the numbers that you may remember is the 13 billion sensors shipped, 13 billion sensors shipped up to date. And I think that now is 14. So in my slide I see exactly. And
so it's everywhere.
It's everywhere, yes. And microcontrollers, 3 billion up to date. So that's a number that we like to advertise. We have a nice marketing stunt that we sell 32 microcontrollers per second.
I like that. 32 micro. Yeah, that's a good number. And that's some of the names as well, right?
Yeah, exactly.
That's cool. So you came here with some of the kits that you have. So I think we're going to walk through some of them. And you're going to tell us a bit about the developer experience, right?
Exactly.
So overall, people perceive hardware development being something that is hard, right? You have to, even if it's sometimes CPUs, but microcontrollers, you have to know about C code, and you have to know about specific tool chains and compile for these esoteric ARM-based CPU-like chips. And so what is it that you guys are doing these days to make the developer's life easier to help them get to market faster?
Okay. First of all, it's all true. So it's hardware is hard.
I've been there.
Yes. But what we're trying to do is first of all to give some easy starting point to get you started really in 2 minutes without coding, without installing any tools. If not a smartphone on your tablet and app. And then from there you get you're accustomed with the whole process of sensing and then seeing the data on the cloud, and then you can start digging into a little bit more. And professional IDE are part of our development ecosystem. So we do provide, on top of the products, we do provide hardware kits that are full-blown examples. Today we're going to talk about the Discovery Kit IoT node, which is kind of a kitchen sink approach, if you want, to the developers. We give you all the technology that we have. We have a microcontroller, part of our low power family. We have motion sensor, environmental sensors. ranging sensors. And then we have 3 radios: Wi-Fi, BLE, and sub-gigahertz. So you pick what you need and
test.
build your, exactly.
And then you can validate this is the kind of hardware you need. You pick the ones you want. You create your own PCB.
Exactly.
And off you go.
But if you want, if you see, and these are actually in scale, we can go, and this is the kit that we're going to play with today, and this is the second kit we're going to play today. Sometimes the developers need an idea of how small can you go, how the integration will bring you to really sensorize every single thing that we do. So and this is the sensor tile. It's a 13 millimeter by 13 millimeter sensor node.
Okay.
It's a BLE connector sensor node. It has a Cortex M4, part of our low power family, connectivity via BLE, and then a full set of environmental and motion sensors.
Awesome. This is awesome. Like that. So you're saying that you can actually get these guys connected in a matter of minutes with no code.
Yes.
You need to show us.
Absolutely.
Awesome.
So the first kit we're going to play with is the Discovery kit. So you unpack it, and you will see all the hardware that I was mentioning, plus Arduino connectors to further expand the capability of this board. There are a couple of USB connectors to the board. One is our ST-Link, so it's a debugger. So it's a service microcontroller that will allow you to access to the main microcontroller for debugging purpose. We're going to connect and expose a COM port to our laptop. And the second is a USB on the go to touch storage and things like that. So we're going to connect these to the right one. And what will happen, some lights will start blinking.
Which you would expect from an IoT device, right?
Obviously. And the other thing that is interesting here is that the board is presenting itself as a flash storage.
Okay.
So you see that it opens up like if it was an USB flash storage.
It's going to be both on Windows and Mac OS?
It works
everywhere?
It works on both.
Cool.
Windows will expose it as a flash drive, and there is a mechanism to drag and drop a precompiled binary file in this flash storage, and then the board will reboot and actually use the firmware that you just did.
So that means that as a user, if I want to reflash the firmware, I don't have to go through hoops with command line tools, whatever. It's just drag and drop of the file.
Correct.
And my board is reflashed.
Correct.
Awesome.
And this is true for every microcontroller when connected to our ST-Link.
Okay. And that's for development purposes, right? You don't expose a USB port on a production machine.
No.
That's for sure, people. You cannot have your machine hacked by someone just plugging in the USB key and reflashing that one firmware, right? Like we see in movies.
Absolutely. No, it doesn't work like that. I always wonder how it works in a movie. But yes, not like that. And so what you do as a developer, you go to st.com www.st.com, and our website with the latest technology that we want to advertise. And right here, I'm looking for Azure. So. And looking what kind of firmware do support Azure, what are the firmware package that supports Azure. We have a couple of options here, and the main one are Xcube Azure and the Function Pack Azure. The other two, the pNucleo is a package of hardware.
Okay.
So between the two, the main difference is one is a cloud connector, so it provides you only cloud connectivity to Azure. The second one will provide also a full application, so it will allow you to connect to the dashboard. It has a pre-burnt connection string to connect to our web services, and also today we're going to pick the function pack. When you pick the function pack, it will connect, and there's a full description of what the function pack is. It runs on this board, supported board, and when you go down, you will find the get software. So
that's the binary you were mentioning earlier.
This is the full package, so it's not going to give you all the binary. It's a big, it's a 300 megs. So 30 meg zip file that once unzipped will contain also that binary. So if I get software, log in with the myst.com, which is an account that we require to register to ST so that we can provide you support. You can get support with your own account through the community that I had just up and running over there, and then you download the firmware. Once you download it, it will look something like this. So it's on my C drive. STMicroelectronics Function Pack Azure 1.
Okay.
So all our firmware packages have the same structure. There is documentation, drivers, the middleware that we're using, utilities if you need flash utilities or other PC-based tool, and then projects, which is where we're going today. So PC, multi-application. We are using the sensor with device management today. There are 6 folders here. There is the binary folder where we're going to go and pick up our precompiled binary. And then in the source and ink, which are the library needed, and 3 folders with the projects for 3 major IDE, IER, Kyle, and the System Workbench, which is an AC6 GNU-based. We're not going to go there and code. We promised we're not going to open up.
No code.
So we go to binary, we select the correct board, and the discovery kit is the BL475E.
Okay.
And we pick up the correct binary, which is the Azure Sense device management with bootloader web, because it connects to the web. And you basically drag and drop it to the discovery kit, and I'm copying it. And now the only action of copying it will flash the device.
Okay.
There are 2 buttons. Okay, it's going on. Perfect. There are 2 buttons on this. One is the blue button, one is the black button.
Okay.
And the black button will reset the board. So we're just going to reset it, and now it's running the new firmware that we just installed.
Easy.
Easy.
No code.
No
I like that. Okay.
Now, what do we do now? So I'm connected via USB.
So you enable the configuration mode. Okay.
Okay. So we can. So we enable the configuration mode pressing the blue button, and I can change the connection parameter. If I'm saying yes, it will ask me for SSID, password, security system, and then you will be able to connect to whatever access point. Right now, let's not do that. It's already configured to connect to
my phone.
To your phone, used just as an access point.
Okay.
And right now, what's happening is that I'm connecting, and I'm sending messages to our own web services running on Azure. Okay, there you go. And now it starts sending messages to Azure. What I do here now, what I could do, there is an NFC dynamic reader also. I could tap my Android phone on the board and send directly to this link to visualize the data. Okay. What we're doing now instead is just copying this link and pasting it on the browser. So I'm basically, this is our STM32 Azure website. Okay. This board is already been registered, and it's now sending data. The device name is its MAC address. The board type is correct. Okay. It's
so that's basically the default binary will connect to your own instance of IT Hub.
Yes,
in Azure.
Our own instance.
So that users can experience that connectivity and flow of data without even have to create an Azure subscription.
Exactly. Right now you are not doing anything.
Okay.
And this website is the code powering this website is available on GitHub, and it's part of our documentation. So you can see what products are we using from Azure to build it, and now it is architected.
Pretty straightforward.
Everything documented from our website. Right now connected and enabled, and what I'm streaming is live sensor data on the web. And so you see temperature, humidity, accelerometer, gyroscope.
So no tools installed. You have a USB serial adapter driver that's been installed by default by Windows anyways.
Yes.
And then you have a terminal that you need in order to eventually set up the Wi-Fi.
Yes.
And that's it. I love it.
Exactly.
Pretty straightforward.
There's more to it. There's more to our instantiation of Azure. We also demonstrate some device management feature here. Okay. So if we click on device management, there is a second page opening up where we basically see, we can observe what the twin looks like and all the properties. But we also can control the device. Yay. We can send cloud messages, and the messages that I have here are pause, stop streaming data, play, start again, or blinking LED. And I think the LED is going to be used over here. That right now, if I want to turn it on, it will. There you go. And this is turned on.
Nice, like it.
So I'm going to send the message, and now it's on. The site said message sent successfully, and now it's on.
So if I want to see the ACK of the IT Hub.
Yes.
Your client. Okay.
And here you see that I sent the message from the terminal.
Okay, so you get the first call, the first experience. I also see call method, and then there's the firmware update as well. So you actually are demonstrating how to do a firmware update.
Yes, we call a direct method to initiate a firmware update.
Okay.
There is a blob storage where we have actually the same firmware image that you have here. But say there is a new one, we're going to update it, and it's going to be hosted on our website.
Cool.
So
I think you said it, but the code that you're using for that default image is available as open source, right? People can go
source code,
find the source code and re-implement what you're doing here with your demo solution that works out of the box. They can just reuse the exact same code on their actual application, right?
Absolutely, and they have source code for the application, for the firmware running on the microcontroller. They have source code for the website that we are experiencing right now. Okay. And all you have to do here is call a direct method. We can do a reboot and or a firmware update, and the blob, the storage, the new binary will be transferred via MQTT. It's a slow process, so it's going to take a couple of minutes to do that.
Yeah,
but we can initiate.
But we get the idea, so you don't need to send it now. We get the idea. IoT Hub gives you all these functions with twins and methods and others that you're leveraging to do your own firmware update, which is actually the way STMicroelectronics does for that specific board.
Exactly.
Yeah, love it. Awesome.
Exactly. So
gizmos.
Maybe not 2 minutes, but
it's
no
pretty straightforward. Pretty straightforward.
Yes. Okay.
So you have another, like the tiny one.
I have another toy. Yes. So let's close this up. So this was a demonstration of a Wi-Fi connected node. So this was needed an access point directly connected. What this is, what the tiny one does, and I have it here packaged in a case, so that you can have a battery charger and a battery and an enclosure. And the idea is that if you want to say do some field acquisition to validate an algorithm they're creating or stuff, we already give you also the tool already prepackaged. So this was a BLE connected sensor node. So it's streaming data to a smartphone application or smartphone or tablet application, available for both Android and iOS. I'm going to use Android today, and I'm going to mirror the screen on the
tablet.
On the tablet. There you go. As you see, and the application is called STBlueMS. Also, the application is available in source code. We have GitHub links to both repository when you can go and get to see how plumbing is done. So this is again the sensor tile and all the documentation. Like I've wrote Azure on my page. If you write sensor tile, you get all the documentation for this board. So
then in that case, what you're doing is you're using the tablet as a gateway to the cloud for the BLE device, right?
Exactly. Exactly. So the first connection that happens here is the sensor node to the tablet. As you see, I'm streaming now temperature data, pressure, and humidity. But I'm also streaming motion data. So as I'm moving the sensor, these are Fusion library taking all the sensing data from the accelerometer, gyroscope, and magnetometer, and rebuilding this dice kind of movement for us. And there's more than you can do here. There's also a microphone. You could send it to a voice recognition engine and all that. But what we're doing today is the cloud logging feature. So I go on cloud. Let me disconnect it first. And I'm going to connect to the same web dashboard that I have today. I could do that we used previously. You could also use a connection string, a different connection string, and connect it to your own IoT hub. But let's use the standard web dashboard. The first thing is asked, it's to click register. So basically, the tablet will send the MAC address of this specific sensor tile and register this kit with the service. It's already registered. And then you basically click the purple cloud button and select which data you want to enable. So I'm accelerometer, temperature, and humidity, for example. Which one you want to see on data, view data on cloud. And you're basically redirected to the similar website. Similar website, but now different board type, different experience. Right now, this one is the BlueMS mobile gateway. So it knows that there is a sensor node connected to the the gateway, it's connected and enabled, and I'm seeing the live data. Yes. Okay. So what we're doing here, we're streaming data to this dashboard. If I get if I recreate the address on a browser, and I do this with so it's the same STM32OD website registering the board through its MAC address. So it's C048. So unique MAC address. I'm connecting now. It recognized that is Blue MS mobile gateway. So it's an application now streaming data. The board is connected and it starts streaming its data.
Okay.
Now to verify its live data, I usually like to do this. So if you put the accelerometer data on the table, you will see that there is you will see gravity on one of the axes. 1,000 millig on one axis, and if you flip it, then you're going to see the gravity is going to change axis. So
there's a way to see one of the other one going up. And
exactly.
Yeah. Okay.
And
there you go. Awesome.
And now it's flipping.
Real-time data. So once again, no coding. However, as you were saying, once again, code is available. So people can start from these projects to start building their own solutions.
Absolutely.
Connectivity to IoT Hub has been like pretty streamlined. You have your own portal to show how to do that. I need to use more of that during my demos, by the way. You're going to hook me up with some of these, right?
Sounds good.
And then basically you can create your own solution based on the same code on your own IoT Hub. Pretty straightforward.
Exactly.
I love that. And integration to IoT Central and the solution accelerators, things are in the work? Or?
In the works, absolutely.
Okay.
So we keep, we are enabling the discovery kit in IoT Central. As you see, there is already a binary.
Yes, yeah.
And you can already create a device in IoT Central and we post instruction on how to do this step by step. And it will be posted as one of the starter kit as well.
Yeah. Well, anyways, IoT Central uses IoT Hub in the back. So it's just a connection string that you have to, but the integration is going to be
absolutely
one level higher real soon. Awesome.
Exactly.
This is great, Manuel. So it's a good overview of all what you have in terms of some of the many demo kits for all the technologies. Developers can get started super fast. We have starter kits right in the Azure starter kit catalog. From STMicroelectronics.
Absolutely.
I think one of them is in there right now.
The discovery kit
is in there.
And also the Nucleo, which is the stackable approach.
Well, you can add your various stacks of sensors or functionality on top of it. Right?
Also, this one, the Nucleo stack is also available.
Okay.
And both in Wi-Fi and Ethernet.
Okay. So we're going to add some links to the catalog pages or to where developers can find information on these boards. And I guess they can also find all the websites for information on STMicroelectronics.
Yes, www.st.com. We keep these firmware packages updated, of course, as Azure releases a new feature. We're going to soon support DPS and DICE as well in our own devices.
Thanks for coming.
Okay.
Manuel, thanks very much. Hope to see you soon.
Thanks,
guys, for watching the IT show. See you soon as well. Bye.
Thank you.